By the end of this video, or sorry, the lesson, you'll be able to find the probability of what's called compound events, if they're independent or dependent, and you'll be able to find the probability of what's called mutually exclusive events. So first, I want to talk about some notation they use. If you see P, and then inside of parentheses next to that, you see something like tails, 5, 9, marble, purple. It's a probability of that happening. So this means the probability of getting tails. All right, so in our case, that would be 1 out of 2. So when I flip a coin, the probability of getting tails is 1 out of 2. We're going to talk about first is the probability of what's called compound events. So two things happening or more. And we've already talked about this a little bit, so probability of like throwing a die and flipping a coin. So what's the probability of getting a 6 and heads? So that is a compound event. So it's made up of two simple events. And we have two different types that we talk about. We talk about independent. They're mutually, I was about to say something wrong. The probability independent events, the first event doesn't affect the second. So if I roll a die and get a 6, it doesn't affect if I flip a coin and get a 1 or a 2 or not. So those are called independent events. Then you have dependent events, where the second event is changed based on the first. So for instance, if I have a bunch of people in the room and I randomly choose somebody to leave the room, then the probability of getting like a girl or something the second time changes because the person who left the room was either a boy or girl, so it affects the probability of getting a girl the second time. So those are dependent events. So probability of independent events, the outcome of the first event does not affect the outcome of the second, so you just multiply those together. So example, rolling a 6 on the die and rolling a 5. Rolling a 6 doesn't affect if I get a 5 the second time. They're not dependent on one another. So it'd be 1 out of 6 times 1 out of 6, so that'd be a 1 out of 36 chance. The outcome of a first probability dependent events, the outcome of the first event does affect the outcome of the second. So you still multiply them together, but it's a probability of A, but then it's a probability of B following A happening. So for example, without replacing the first card, choosing an ace and then a king. So if I choose an ace out of the deck, the chances of getting a king are higher because there's one less card there that is not a king. So we got to decide, are the events dependent or independent, and then we multiply our events together based off of that. So a bag contains 3 red, 4 blue, and 6 yellow marbles. 1 marble is selected at a time, and once the marble is selected, it's not replaced, so it's not put back in the bag, find each probability. Since it's not put back in the bag, pulling out a marble changes the probability for the second, so that it is not replaced, so this is dependent, okay, because it lessens the amount of marbles are in the bag, so it changes the probabilities. All right, so we want to know what are the probability of getting 2 yellow. So the first thing we need to know is how many total marbles are in the bag. So let's see, 3 plus 4 plus 6, there's 13 marbles in the bag. Okay, so that's going to be helpful. So we want to know what's the probability of getting 2 yellow. So pulling out a yellow, setting it aside, and then going back in the bag and pulling out another yellow. So the probability of getting a yellow the first time, there's 6 yellows and there's 13 in the bag total. Okay, so 6 out of 13. So what's the probability of getting yellow the second time? Well, now there's just 12 in the bag, okay, because I pulled one out. And the one I pulled out was yellow, so now there's just 5 yellows left. So I pulled out a marble, it was yellow, so now there's 5 marbles that are yellow left in the bag, because there was 6, and there's only 12 marbles left. So now I have a 5 out of 12 chance of pulling out a marble. When you go to multiply these, you can multiply straight across. So I get 6 times 5 is 30, and then multiply 13 times 12. The easiest way to do that is to just put it into Desmos. So that's what I did. I did 6 divided by 13 times 5 divided by 12, and I got 5 over 26. And we want to select that fraction button in Desmos. So you click on that because it's going to give you a decimal when you first do this, but we want a fraction, so make sure you hit the fraction button because all of our answers for these probabilities are going to be written as fractions. All right, the probability of getting red and then getting a yellow. So in the first turn, let's say there's 13 in the bag. Of those 13, 3 are red. So of the 13 in the bag, 3 are red. Now when I go to multiply, for the second one, now there's just 12 in the bag. Okay, how many of those are yellow? There's still 6 yellow in there. Because when I pulled out my marble, I pulled out a red one. So that didn't affect how many yellow are in there. It only affected how many were in there total. So when I multiply those, I get 3 out of 26. All right, 3 out of 26. All right, so now we want to find the probability that we get a blue, then a red, and then a yellow. So we need to multiply all 3 of those events together. So for the first event, there's 13 in the bag. 4 of them are blue. For the second event, now there's just 12 in the bag. And since we pulled out a blue, there's 3 left that are red. All right. Third time, now there's 11 in the bag. How many of those are yellow? 6. All right. Again, you can multiply straight across. So 4 times 3 times 6 over 13 times 12 times 11. But you can also, again, type in Desmos, and I would get 6 out of 143. Again, I would practice typing those as well to make sure you're getting the same answers as me. So these were dependent because when I pull out a marble out of the bag and I don't put it back, then it affects how many marbles and what types of marbles are in those bags. George has 2 red socks and 2 white socks in his drawer. What is the probability of picking a red sock in a white sock if the first sock is not replaced? Again, since it's not replaced, this is dependent. Okay, so there's 4 socks total, okay? And we want to know the probability of pulling a red sock first. There's 2 red socks in there, so 2 out of the 4 are red. Times, now there's just 3 left because I pulled one out. And since I pulled out a red one, we want to know, we pulled out a red one, so there's 3 left in the drawer, but that still leaves 2 of those, of those 3 being white. So 2 of the 3 are still white, right? So what I pulled out was red. So I multiplied those together, and I get a third of a chance. So again, my first pull, there's 4 socks in there, 2 of them are red. My second pull, there's 3 socks in there, and 2 of them are white. So if I want to know pulling out a red and then a white, if I'm not replacing it, then it'd be 2/4 times 2/3, which is 1 out of 3. Phyllis drops a penny in the pond. Then she drops a nickel in the pond. What is the probability that both land on tails, with tails showing? These are independent because throwing the penny has no effect on the nickel. So if I get heads on the penny, I still can get heads or tails on the nickel. It's not affected at all. So both with tails, so I have a 1 out of 2 chance of getting tails on the penny, times 1 out of 2 chances of getting tails on the nickel, because there's 2 sides to a coin, and one of those sides is tails, so 1 out of 2. And I multiply those. 1 times 1 is 1, 2 times 2 is 4. So I have a 1 out of 4 chance of that happening. A die is rolled and a penny is dropped. Find the probability of rolling a 2 and then showing a tail. Again, these are independent because the first event doesn't affect the second, so rolling a dice doesn't affect the penny. What's the probability of rolling a 2? One of the 6 sides is a 2, so there's 6 sides. One of those is a 2, and then a tail would be 1 out of 2. So that probability would be 1 times 1 is 1, 6 times 2 is 12. So 1 out of 12 chance of that happening. So dependent events, the first event affects the second. Independent, then with it, let me say that again. So independent, the first event doesn't affect the second, but the dependent events, I do something with the first event and affect something with the second. Now we're going to talk about the probability of mutually exclusive events. So let's define what mutually exclusive means. So mutually exclusive events, are events that can't happen at the same time. Cannot happen at the same time. They're mutually exclusive. Okay, so for instance, let's say I said, hey, I'm going to flip the coin. What's the probability of getting heads or tails? Right? Okay, so I can't get heads or tails at the same time. Either when I flip the coin, I'm going to get heads or I'm going to get tails. So I should say I can't get heads and tails at the same time. I'm going to get heads and get tails. So in that case, we would add those together. So the probability of getting heads is 1/2. The probability of tails is 1/2. And when I add those together, it's 2 over the common denominator 2, which is 1, meaning 100% chance. Whenever 1's 100% chance. So I flip a coin and said, what's the chance of getting heads or tails? You're going to say, that's 100% because they're mutually exclusive. I cannot get heads and tails at the same time. So if we look at number 5 here in our examples, we're going to talk about a card is drawn from a standard deck of playing cards. Find each probability. Okay. So the probability that my card is red or my card is black. So when we talk about a deck of cards, there's 26 red, there's 26 black. Half are red, half are black. 13 diamonds, 13 hearts, which are both red. 13 spades, 13 clubs, which are both black. All right, so if I want the probability of red or black, there's 26 out of the 52 cards are red, plus the black, 26 out of 52 are black. Their common denominator is 52. 26 plus 26 is 52. So again, that's a probability of 1. 100% of my cards are red or black. If we look at example 7, what's the probability of getting a queen or a card less than 3? So 4 of my cards are queens. How many of my cards are less than 3? So the only cards less than 3 are 2s. We're not going to include aces. We're going to say aces are not a number. So only my cards with a 2 on it are less than 3, and there's 4 of those. All right, so 4 plus 4 is 8. 8 over 52 reduces to 2 over 13. And again, you can just add those in Desmos if you want. Okay, 4 plus 4 over 52 plus 4 over 52. Make sure you hit the fraction button. I have a 2 out of 13 chance of pulling a queen or a card that's less than 3. Number 9, what's the probability of getting a diamond or a spade? There's 13 diamonds, there's 13 spades, so we're going to add those together and I get a half, 26 out of 52, which is half. You also could say 1 out of 4 cards are diamonds, 1 out of 4 cards are spades, 1 out of 4 plus 1 out of 4 is still a half. What's the probability? Let's look at number 8. What's the probability of getting a 5 or a 6? All right, there's 4 5 cards, plus there's 4 6 cards. And when I add those, I get 8 out of 52 or 12 out of 13. Now, if you notice, I did 5, 7, 9, 8, and I'm going to come back and do 4 and 6 because they are a type of mutually exclusive, but they're a little bit different. Okay, so we're really careful because there is some overlap there. Okay, what's the probability that I'm going to get a jack or a red? If you notice with all these questions, they have the word or in them. And when you see the word or, we know we're going to add. So we should mark that as a note. Or means we're going to add. So what's the probability of getting a jack or a red? So first, the probability of jack. There's 4 jacks out of the 52 that are 4 out of the 52 cards are jacks. There's 4 jacks. Plus, what are the chances of getting a red? And we're talking about when we're pulling at once. We're not talking about probably getting a jack and then what's the probability of getting a red. That's different. We're talking about in one pull, what's the probability that card's going to be a jack or it's going to be a red. The other case was what we just talked about, which is compound events. So it's probably getting a jack and then getting a red. Then we're talking about multiplying. But we're talking about in one thing, what's the probability that this is going to be a jack or a red? So 4 of the 52 are jacks. Then we want to talk about the reds. So the probability of reds, first of all, there is 26 red cards in the deck. However, we've already included 2 of those reds in the count of jacks because there's a diamond and then there's a heart. So we're going to have 24 left. Okay? All right, so I think about it kind of like a Venn diagram. Here's my jacks, here's my reds, and then there's 2 that kind of overlap in there. Okay, so I have 2 that are jacks that aren't red, and then I have 24 cards that are red but are not jacks. Okay, so that 2 plus 24 will still be 26 reds, and then 2 plus 2 will still be jacks. Okay, so 4 plus 24 is 28 over 52. Whoops. And that reduces to 7 over 13. All right. Now we're going to talk about the probability of jack or clubs. Okay. So the probability of getting jack is still 4 over 52. The probability of getting clubs is 13 out of 52, but one of those is a jack, so I'm going to make this a 12. Okay? And that adds up to 4 over 13. Okay, so they're still considered mutually exclusive because there's a little bit of overlap with those two. So those two are a little bit different. So be careful of that. If you're with your ors, you know you're going to add, but if those overlap a little bit. And I'm looking at your classwork. And let me see. I don't see any that overlap a little bit. Queen heart or queen of diamonds. Yeah. Okay. So when they're mutually exclusive, so when you see that word or, you're going to add those probabilities together. All right. So I want to do a few more examples to kind of clarify dependent independent events. So a number cube is rolled and the spinner is spun. Find each probability. Okay, so these are independent events because when I roll a cube, it doesn't affect what type of shape or I'm going to get in the spinner. Those are independent events. And again, we have ands here, so when we see those ands, we know we're going to multiply. So those ors we're going to add. Those mutually exclusive events are when we're going to add. So the probability of getting a 2 when you roll a cube is 1/2. the probability of getting a green triangle, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 of those. One of those 8 is a green triangle. So that is going to be 1 out of 16. Okay, so I have a 1 out of 16 chance of getting a 2 and a green triangle. What's the probability of getting an odd number in a circle? When I roll a die, the different odd numbers I can get are 1, 3, and 5. That's 3 of the 6 times a circle. So let's see how many circles are there. 1, 2. So there's 2 circles there, if you see. A blue circle or a white circle. So I have a 2 out of 8 chance of getting that. And when I multiply those together, I get 6 over 48, which is 1 out of 8. What's the probability of getting a prime number in a quadrilateral? So let's see, 2 is prime. Let's see, 1 isn't prime or composite. We don't consider that a prime or composite number. 2 is prime. 3 is prime. 4 is not prime because it's divisible by 2. 5 is prime. And then 6 isn't prime because it's divisible by 2 and 3. All right, so again, that's 3 out of the 6 numbers on a die are prime. And how many quadrilaterals do we have? Let's see, I might have a square is a quadrilateral, a rhombus is a quadrilateral, a rectangle is a quadrilateral, and a trapezoid is a quadrilateral. So that's 4 out of 8, which is 12 over 48, which is a fourth. What's the probability of a number greater than 4 in a parallelogram? So numbers greater than 4 would be 5 and 6. That's 2 out of the 6 times a parallelogram. Squares are a parallelogram. A rhombus is, a rectangle is. So that's 3 out of the 8, which is 6 out of 48, which is 1/8. So again, those are independent events because one doesn't affect the other. There are 5 yellow marbles, 1 purple marble, and 3 green marbles and 3 red marbles in a bag. Once a marble is drawn, it is replaced. Find the probability of each outcome. So first of all, we need to find the total number of marbles. So the total number of marbles, let's see, 5 plus 1 plus 3 plus 3 is 12. So there's 12 marbles. And we want to find the probability of each outcome. It's replaced, so it's independent. Okay? Independent. Oh my gosh, I forgot how to spell independent. God bless America. I have it on this piece of paper. Independent. Oh my goodness. It's like I was doing it the first time. All right. How about a purple and then a red? So 1 out of the 12 is purple times, how many are red? 3 out of 12. Notice I don't have to change the denominator of the second one like I did in the examples we did at first because these are independent because it is replaced. I'm putting it back in the bag. All right, so that's 4 out of 144. So that's 1 out of 48. How about a red, then a green? So there's 3 red times there's 3 green. Multiply those, I get 1/16. 2 green marbles in a row. So how many green marbles are there? There's 3. And I'm replacing it, so again, there's 3. Okay, so took out a green, put it back. So now there's still 3 green. Again, that's why it's independent. And I get 1 out of 16. I'm going to have you do those other 3 for classwork. Okay, those other 3 you can do for classwork. But let's do 2 that, again, that are dependent. There are 4 yellow marbles, 3 purple marbles, 1 green marble, and 1 white marble in a bag. Once a marble is drawn, it's not replaced. So now we're talking dependent, so we need to change things. Okay, so those are dependent events. It's going to change. My second event is going to be changed because of my first event. Okay, so first of all, let's see how many we have total when we first draw. 4 plus 3 plus 1 plus 1. There's 9 in the bag. Okay, so a purple, then a white. 3 out of the 9 are purple. And now we're going to multiply. Now there's just 8 in the bag because we pulled out the purple and we did not put it back. So again, that's unlike that 5, 7, and 6 we just did when we were putting them back right back in. So those are independent. All right, there's still 12 in a bag. What I pulled out doesn't affect for the second one, so it was still out of 12. Let me see, how many white? 1 is white. So I have 3 over 72, which is 1/24 when I multiply this. All right, then a white, then a green marble. So what's the probability of getting a white? A white is 1 out of the 9 times a green marble. Now we only have 8 and we have 1 green. So we multiply those, we get 1 out of 72. So dependent and dependent, independent, you're going to multiply those. So the probability of things happening and this happening. So we're going to multiply those together. If it's dependent, you got to change your numbers a little bit in the second event. If it's independent, you just multiply them together. For mutually exclusive events, that you'll see the word or, and you're going to add those things together. So now you're going to finish this up. You're going to do 13 through 22, and then you're going to go and do 1 through 16.